Are you recording tonight, Fred?
I just hit record. You're welcome. To the cloud.
To the cloud even. So now Rob isn't gonna have to wait until tomorrow afternoon for me to upload it?
I'm just gonna forward him the email when it's done.
I tried to send it to him, share file Wednesday, and then at 2 o'clock, I was looking at my outbox for a different one, and that was still sitting in there from like 9:30 in the morning.
Whoops.
Yeah, I had to log into share file. Whoops.
Send to a copy.
Double fist in the coffee.
Double busy.
We don't have to pee. I'm gonna try to make it the whole class without peeing.
Let's see if you make it.
Right? Unmuted? I'm
Yeah,
in.
you're good to go.
I'm in. I'm good to
I'm
go.
gonna shut the,
This thing?
yeah, where's the?
Oh,
Don't let us dream about being outside.
Just throw a bad glare behind me.
So Brad's in a terrible mood because the cap's lost.
It's still, they're still alive. Hey, one of those. The Penguins gave up a 3-1 series lead in 2011.
It's true.
It's totally possible.
It's
They've
true.
been out-
That's just stinks.
They've been outshot 65. The Caps have 65% of the offensive opportunities.
It's crazy.
It's nuts. We're gonna do.
Just keep watching and getting frustrated.
Yeah,
So Minnesota fans.
That's right. Every sport, man.
I mean, it's only been 30 years. Why would I expect them to start winning now?
Welcome to Minnesota. All right. Well, we'll get started. Yeah, do you like it?
I love it.
It's pretty awesome, isn't it?
No, I
That was my gift today.
super cool.
Yeah, I
Yeah.
came in. I was like, what are they doing? Whoa, nice.
Yeah. Yeah. Rob did that. Kevin Sea Change is who printed it.
Oh, cool.
And then Blue Tricycle was the marketing people.
Definitely got the colors right. Going with that
Yeah.
dark gray with the orange letters.
Yeah.
You were saying that they thought maybe doing orange was a bit too much.
It's nice. It sticks out.
That dark gray
Cool
with
pop to the front.
it really,
Really?
yeah.
Makes you notice it.
really
If you wouldn't-
like it.
If it wasn't orange, you'd just walk by it and wouldn't even notice.
Yeah.
And so when we were talking about it, I didn't know that they were going to do it today. Hey, when we were talking about it, I wanted it, every time we walk through there to remind ourselves, kind of why we do what we do.
It's awesome.
Okay, class 12, it's Thursday. I think the consensus is people are tired today.
I like the ratio of men to women today. Boom!
We got 4 versus 4. What do we, chop liver?
They don't count. Strawberries never count.
Come
What do we,
on!
chop liver?
That's pretty cool.
It is cool. Yeah, that's a good point. We need more women in this industry. There's definitely a shortage. There's a shortage overall, but shortage of women, a shortage of minorities in general. I mean, it's good to see a diverse group. All right, so today, class 12. Now, when I was preparing for 12, this class, I think we can crunch in the rest of the book and then just do the test on Tuesday. Get our Thursday back. That's pretty BA, I think. Yeah, right? So today, I got 2 quizzes popped into today, which will be pretty simple. We're good at the quizzes and stuff. We'll start off with the quiz. It's quiz time.
What is it about you really get the exact same question?
Yeah. I make the same syntax mistakes every time I code in Python. Every single time. I forget colons or I forget to indent. Every single time I'm like, are you serious? So yeah, I don't know what it says about us, but I do the same thing.
You can't get it through my head.
All right, so here's our quiz. This is going to be on domain 6, which was not all that long ago, I don't think. Maybe last Thursday or something. So first question, which software testing level tests software after updates, modifications, or patches? Acceptance testing is done usually at the end, and that's done by the users themselves. So whenever you see acceptance testing, you see users in there then, or owner, that would be acceptance testing. It doesn't really say anything about that. Integration testing is how it integrates with other systems usually. Regression testing is how it works after you update. So that's the answer. And then unit testing is testing portions of the functionality of the application. So that's our answer, C. What is the type of testing that submits random malformed data as inputs into software programs to determine if they will crash? Black box, combinatorial, fuzzing, or pairwise? Fuzzing is the right answer. That's we would use a fuzzer for that. Can't remember. Yeah, there you go. So C. And then I didn't know what pairwise testing is, so I had to look it up. I thought it was like just not even a thing. So I was going to stand up here and say, pairwise testing is not even a thing. And I look it up and I'm like, it is a thing. Okay. So I don't know. Do you guys remember seeing it in the book anywhere? Pairwise testing? Well, turns out it's a thing.
I don't remember on the test.
No, I doubt it's going to be on the test. But it is I guess, a type of combinatorial testing. So it's cool. What type of software testing tests code passively? So passively meaning it's not actively running. That is static testing. If it was running, it'd be dynamic testing. Black box testing is testing without any really internals or information about things, and white box testing would be kind of synonymous with having, having knowledge of source code, diagrams, stuff like that. So this is static testing. So far, we're 3 for 3. Any questions so far? Pretty basic. Your quiz. So on Tuesday, I will be late. My daughter has a choir concert, right? Those are important to be at. So you'll be leading Tuesday, and we'll just be doing practice tests. The practice test questions will be more difficult than the quiz questions from the book. So it should be
Very
more
convenient, you won't be here for that. So
right. I know you get to be the guy and be like, it's
What?
B, and you're like, oh crap, it's C.
I'm totally taking the class consensus.
Yeah, that's what I do too. When it's like, gosh, I don't know the answer. What do you guys think? C, yeah, C. Oh, B. You guys were all wrong. I knew it was B. But it will be more, I think, challenging on Tuesday, which is good. And then I'll be here at some point in the day, and then I can heckle. So what type of penetration testing begins with no external or trusted information, which is kind of a weird way to, I think, ask this question, and begins the attack with public information only. This would be a zero knowledge test. Full knowledge test would be everything, system, diagrams. Usually you're working with the client on a full knowledge test. So if you have questions along the way, you're asking them questions about what does this mean and that. Partial is in the middle. Gray box would be sort of the same as partial testing. This is zero knowledge. What type of assessment would best demonstrate an organization's compliance with PCI DSS? In case you didn't know what that is, that's the payment card industry data security standard. A, audit, B, penetration test, C, security assessment, or D, vulnerability assessment. You guys think on this one? Actually, I'm going to ask questions. What do you guys think? I know the answer, but because I created the. Yep, it's an audit.
So audit and assessments are considered two different things?
For the book, they are.
Okay.
And sometimes in practice, in the real world, we'll say that they're different too. To me, audits are checkbox. The thing says this, are you doing that? Whereas an assessment is, are you doing this? No, okay, what's the impact of it kind of thing. So this is an audit because the data security standard is very clear, very structured. It's checkbox, either you're doing it or you're not. So audit would be the best answer for this one. What type of test provides internal information to the penetration tester, including network diagrams, policies, and procedures, and sometimes reports from previous penetration testers? This is full knowledge, right? I went over this one already. And that's common. We just did one for a big bank, and there were two parts to the penetration test. One was validating that they had remediated the previous penetration tester's findings. So obviously we had full access to their report. And then the second part was just a different type of test. It was, the scenario was, assume that somebody has compromised a system already internally. What can they do, you know, to get at it? Because they're doing network access control and all these other things on the port. So they're assuming that we got it, that an attacker had gotten in maybe through some malware that, you know, the user opened. So that was a full knowledge test, both of them, because one, we're proving that something's been remediated or not, so we have the reports. And then the other test was also full knowledge too, because we were just sitting there with you while we were trying to get bypass things. And then as we ran into hurdles, we'd have you know, lower the defenses and then try again and see where we get stuck again and stuff. So what can be used to ensure software meets the customer's operational requirements? So this is customer, their requirements. That's the definition of C. That's acceptance test. The quiz ones, I mean, the ones in the book are pretty, the ones in the book, in case you didn't know that, these are pretty easy, I think. I'm looking forward to Tuesday. It'll be a little more difficult. So what term describes a no-tech or low-tech method that uses the human mind? How do you say it without saying it like that? Human mind. To bypass security controls. Fuzzing, social engineering, word dialing, or zero knowledge test? B, yep, social engineering, the human mind. It's like when you just look at somebody and you're just like, and they give you your wallet. Remember I was telling you before, so as I was preparing for today, I was, remember the micro expressions? So it's Paul Ekman is the guy who does the micro expressions. That's a picture of his website. You can learn how to read micro expressions and test and everything. That's kind of when you take your social engineering to the next level. What term describes a black box testing method that seeks to identify and test all unique combinations of software inputs? There's a key word in there, combinations. So combinatorial software testing. The difference between combinatorial and like fuzzing is trying to make the system crash. And it's not, it doesn't have to, it's random data rather than this is more structured inputs. This is a big scenario, I guess. You are the CISO of a large bank and have hired a company to provide an overall security assessment and also provide a penetration test of your organization. Your goal is to determine overall information security effectiveness. You are specifically interested in determining if theft of financial data is possible. Your bank has recently deployed a custom developed 3-tier web application. You know what a 3-tier web application is? You have front end, then an application, then database, and 3 tiers. That allows customers to check balances, make transfers, and deposit checks by taking a photo with their smartphone and then uploading the check image. In addition to a traditional browser interface, your company has developed a smartphone app for both Apple iOS and Android devices. The contract has been signed and both scope and rules of engagement have been agreed upon. A 24/7 operational IT contact at the bank has been made available in case of an unexpected development during the penetration test, including potential access. That's a lot of words.
And you know, it says for 11 through 14, and this happened multiple times where you get a scenario that affects multiple questions.
Yeah, and this is common on the test. And so the key is being able to pick out, you know, key points in there that are going to be relevant to the question. So the question is, what term describes a holistic approach for determining the effectiveness of access control and has a broad scope? You almost don't even need that scenario for this question. Security assessment? Yep. Yep, I agree. An audit would be a checklist. It's not really holistic. I mean, it could be audit, I suppose, but assessment's your best answer. Assuming the penetration test is successful, what is the best way for the penetration testing firm to demonstrate the risk of theft of financial data? It's successful, defining success, right? Success for the pen tester or success for the, the client? Instruct the penetration testing team to conduct a thorough vulnerability assessment of the server containing financial data. Instruct the penetration testing team to download financial data, redact it, and report it accordingly. Instruct the penetration testing team that they may only download financial data via an encrypted and authenticated channel. Or D, place a harmless flag file in the system on the same location as the financial data and inform the penetration testing team to download the flag. D, right. B and C are a little scary because B and C might be regulatory issues, right? Because that would be a compromise of confidentiality, even though you've hired them. Don't rely on the contract to save you. What type of penetration test will result in the most efficient use of time and hourly consulting expenses? Automated knowledge. I don't know what that is. Full knowledge, partial knowledge, or zero knowledge. B, right? And the reason why B would be, I think, most efficient, you know, if you know the steps in the penetration test, it usually starts out with reconnaissance and then enumeration and, you know, so on and so forth. I can cut all of reconnaissance out and a big portion of the enumeration out and just dig in. So it's a lot more efficient. We would like to have a security firm test the new web application, but have decided not to share the underlying source code. What type of test could be used to help determine if the security of the custom web app, or help determine the security of the custom web application? Secure compiler warnings. Well, if you don't know what it is and never heard it before, you can probably cross it off. I don't know what that is. B, fuzzing. D, static testing, or C, static testing, or D, white box testing. What was the question again? Oh, not to share source code. Okay. Fuzzing? Fuzzing would be good. Yep. And static testing would, static and white box would both require source code, right? So yeah, good one. During the course of the penetration test, the testers discover signs of we've had this same similar question, of an active compromise in the new custom developed 3-tier web application. What is their best source of action? Sounding like that question either. Like the source of action? Probably my damn mind, my brain. It's the source. But okay, so attempt to contain and eradicate the malicious activity. Continue the test, quietly end the test, immediately call the operational IT contact and escalate the issue, or D, shut down the server. This one's pretty simple, C. All right, that's it for that quiz. Pretty simple. A little bit of review here. We've talked, we did get through the BCP DRP stuff, but we're just gonna back up just a little bit just to make sure we covered it adequately. But we did get through incident response management, e-discovery, all that good stuff. We'll get into this a little bit more. And this one's kind of hard if you don't work with DRPs or BCPs a lot. There's a lot of memorization, you know, WRT and RPO and RTO and MDT and MTD. So again, the disaster recovery plan, do you remember what that is? It's shorter term, usually IT specific, part of the, usually fits in with the BCP, which is the bigger one. The continuity of operations plan, which is sort of like a BCP, but it's a little more focused. It's for keeping the business running during the disaster. Business resumption recovery plan, continuity of support plan, cyber incident response plan, occupant emergency plan, which is all around personnel safety, and the crisis management plan. The crisis management plan is kind of easy to remember because it's a management plan. It's for managers. It doesn't, you know, handle everybody. So that one's kind of easy. Occupant emergency plan is easy to remember. Cyber incident is easy to remember. Continuity of support is keeping like help desk running and that stuff. That one's kind of easy to remember. Business resumption recovery plan and how that differs from the continuity of operations plan. That's a little fuzzy, you know, it's a little fuzzy in my mind too. So maybe spend a little time delineating what those two are. Really, continuity of operations is keeping things running during the incident or the disaster, whereas business resumption recovery is it's kind of over now and now getting back to normal. So slightly different, but sort of overlapping. There's that again, just for your,
Really good.
what?
That's really good.
Yeah,
Studying out right there.
now you'll definitely want to memorize this. Continuity of operations plan, again, procedures required to maintain operations during the disaster. The key is during the disaster. It keeps things running while a disaster is still happening. Includes transfer of personnel to an alternate DR site and operations of that site. The business recovery plan is getting things back after the disaster is sort of done. Details the steps required to restore normal business operations after recovering from the disruptive event. May include switching operations to an alternate site back to the repaired site. You would do the, what do they call it? The salvage team would go in and salvage the site first before that happens. Picks up where the continuity of operations plan is complete, the one above it. But these are the two that I think are the most related, you know, in the plans that you'll get tested on. Continuity of support plan, that one's, you know, again, pretty self-explanatory. The continuity of support is keeping, I always think, whenever I hear of support, I'm thinking like IT, tech support, help desk kind of folks, which is what it is. A cyber incident response plan, we've talked through that one already. That one's pretty self-explanatory. Occupant emergency plan really is about getting people out efficiently, safely. It's about personnel safety and facilities. Crisis management plan, the big thing here is it's about keeping managers in communication, in coordination with each other. That's what the crisis management plan is meant for. Part of the crisis management plan is the crisis communications plan. That's that. Also part of that crisis communication plan is calling trees. And we've got manual calling trees and, you know, the automated calling trees. It's about notifying everybody that should be notified. Ideally, everybody in the organization be notified, even down to the custodian. I mean, you want everybody to know, because you also don't want anybody talking, right? We have to control the communications. You normally have, you know, like PR folks do those things. Two-way reporting has to be, you know, in place for the calling trees. There's an example of a calling tree. We've been through this already, but I just kind of wanted to get us, you're going to get tested on this for sure. Automated calling trees, there's a lot of services that you can subscribe to. There's web-based software as a service solutions for automated calling trees. It's easy, just activate it and all the calls go out and people push the numbers that they got in the call, they acknowledge, and then you have a nice, you know, web interface report. That's kind of nice when it's web, because then I can get it anywhere I've got a browser on your phone. It's really nice. Crisis communications plan, part of the crisis management plan again. Part of that will be setting up the emergency operations center. That's kind of the command post where, you know, you'll run the company, or at least a part of the company. One of the things you don't want to overlook is having vital records kept off-site. Yeah, having duplicates is a good idea. Executive succession planning, we already talked about this. This never happens, so we don't have to worry about that. Entire executive teams to be outside at distance meetings. That's a common mistake. I wonder how many times an entire executive team has been wiped out because they went to a retreat together. You think that happens? Have you ever heard of that? I've never heard of it. Because our management team is going to be going on a retreat towards the end of this year. Maybe I shouldn't tell you guys, because you guys are going to like take out the whole team. I just don't know if that seems like paranoid. You know, I mean, I suppose it could happen.
I've looked at places where when we would just for DR testing, we had to fly on separate planes. Take separate, we couldn't take the same cab from the airport.
I've just never heard of an entire management team getting wiped out because they, you know, went on a trip together, or went on a retreat together, or were at a conference together.
Because they're practicing this practice.
That's probably true. That's probably true.
Traveling together.
Yeah. It gives me a reason not to have to go with Kevin.
Don't ride in the same car.
If Kevin wants to, you know, hey, let's go on a retreat or something, I can't, man. Can't do it. It's in the book. Yeah. Plan approval. So again, senior management, the highest up in the chain. If you can get the board, that's great. But that way you've got, you know, kind of ultimate authority to execute and run through this plan should something happen. Backups availability. Again, we've talked about this before, and the different types of backups. Knowing how a lot of people don't test their backups, so testing full metal restores is important. It sucks to find out that, or here's one that I've run into before, that the backups are encrypted, but the encryption key is at the main site that got wiped out, and so they had no way of getting the data back because the encryption key was gone. So that's
Secure.
yeah, you're not getting on it again. So WTR or MTTR, mean time to recovery. Yeah, we talked about all that. Hard copy data, having paper. Sometimes people run business processes, have a separate business process for disasters where they'll rely on paper and won't rely on any electronics. We've talked about full incremental. Any questions on full incremental differential backups? And you'll probably get tested on that too. The number of tapes that I would need to restore, for a differential would be the last full and the last differential, right? Whereas incrementals would be the last full and every backup I've done since then. So every incremental, if I run daily incrementals, and I run fulls on weeks, on a weekly basis, I may have 6, 7 tapes that I'll have to restore from. You guys still using backup tapes? Is it still a thing?
Still a thing. I still use this still.
Yeah, there's still some tape libraries out there.
Phasing it out.
Yeah. Electronic vaulting, we talked about before. That's what everybody's doing now, right? We're all doing backups electronically, and it's immediately available. Yeah, so you guys are pretty comfortable with that. Remote journaling and database shadowing. We're going to hit database shadowing again when we get into today's domain, when we talk about just database security, database shadowing and database replication and how they're different. But database shadowing is having an exact replica of the database. The only difference is the shadow database is not being used. So you have the production database still being used. That data that's being written to there is also being written to the shadow database, but it's not live. Remote journaling is essentially storing transaction logs from the database somewhere remotely. The remote is a key word. So if that database server were to crash, you could restore from backup, restore transaction logs, and lose less data. Software escrow, this is very important. Software escrow, the purpose for this is if you're having outsourced software development and that company goes out of business or they go rogue, something like that, you can still get your source code so you don't have orphaned source code that can't be supported anymore. One of the really big companies that was in this area a while back was Bell Mortgage. You know who Bell Mortgage is? Their software sort of got orphaned. It was awesome software. It was all their mortgage processing software. And they still use it, but it costed them quite a bit to get new software developments to get up to speed without really access to the source code. They kind of had to build a parallel system. So escrow is really important if you're having any outsourced software development. DRP testing, training and awareness. We've talked through why all these things are very important. You'll need to know the different types of tests that you do in DRPs. So we talked about walkthrough, structured walkthrough, tests, checklist tests. Those are kind of synonymous with each other. Parallel processing, partial disruption, full failover, all those. So in order to show that the DRP is actually working, you need to test it. Different types of tests. There's DRP review, which is sort of like tabletop, but not really, because we're not actually going to work through it together. It's giving everybody on the DRP, on the disaster recovery team, a copy of the DRP and say, read it and tell me if it's full and all that stuff. Checklist is known as consistency testing. This is also walkthrough testing. So we're going to sit down, we're going to go through the checklist and make sure that it is going to function as much as we think it can. Parallel processing, this is running in failover, running from the DR site and the main site sort of in tandem. partial and complete business interruption. You have to have some gumption, I think, to do complete business interruption testing. Unless you have a full redundant data center. But even then,
So nerve-wracking.
yeah, what if it doesn't come up? Starting emergency power, these are all things, again, to test, calling tree, training test every part of your disaster recovery plan, awareness. So two things, training and awareness are different, right? Training is teaching you how to do something. Awareness is keeping you aware of something. This is awareness. So people know, hey, once a year, once, a quarter, whatever, you're reminding the disaster recovery planning team that you have a disaster recovery plan. This is where it is. You've got a test coming up in 3 months. Get yourself familiar with it, that kind of stuff. Maintenance, so change management, we're going to get into more of that today anyway. These are common mistakes. We've been through those, and the bottom 3 should be bumped up to the top. But I don't think those are done in any specific order. Now, this is where we went kind of fast on Tuesday. These are, you'll need to know, you'll probably need to know these standards. You won't need to know the details, what the standards all say, but you need to know that there are, essentially 3 standards that might be referenced. One is NIST SP 800-34. The other one's going to be ISO. And then the last one will be that Business Continuity Institute, the BCI one. So here's NIST SP 800-34. That's where you can download it if you want to. Again, you don't have to know it in detail, but just know that that is the number for doing DR planning. This is ISO. So ISO is 27000 or 27031. Again, you don't have to get this one because you'd have to pay for it if you're going to, because these are all copyrighted. But knowing, I think what's on the slide should be enough for you in the exam. And then BCI. The BS, I don't know if you, I'm not sure you'll have to know that one, but it's there for reference.
I don't remember either of those.
Yeah, I think Business Continuity Institute is kind of one of the major ones actually in the industry. So it might be on that one might be on the exam.
Look at the PD one. That
This one looks
rings a
familiar
bell.
to
Now
you.
I see the PP one.
That's the one you wanted to go to. BCI convention.
I'm dying to get there. I just can't
I
get
don't
the,
remember the.
I just can't get the budget.
Wait.
I can't get the budget approved. Yeah, it's wild, I'm sure. That's it. So we're done with that. I'm not going back to that ever again. So you guys survived domain 7, well, until next year. Did you guys survive domain 7? Let's do a quiz. Bam. It's kind of a happy picture.
Yeah, it's cute.
Again. All right. So what type of backup is typically obtained during the response, aka containment phase of incident response? Did you guys get that? The people that asked for it, the spreadsheet thing? I made a new version. Well, 'cause, yeah, 'cause there were some things that I didn't like about it. So if you want a copy of that DR stuff, shoot me an email. My email's there. We can shoot Brad an email and I'll get you a copy. I posted it to the blog, my blog today, under a Creative Commons license, so anybody can use it. You know how easy it is to get Creative Commons license? Have you ever done that before? You go to the website, you choose like 4 options, and then you have the license. You just copy and paste it. I mean, there's nothing you have to like fill out or anything. I've never actually done that before until now. It's cool. What type of backup is, okay, whatever. During the containment phase. So incremental wouldn't do me a bit of good. A full backup, maybe. Differential wouldn't do me a bit of good in an incident response. But the best answer here would be a binary copy, right? A bit block level copy of the drive. So I would conduct my analysis, on that. So D. Binary. That in we don't have Will anymore. When we had Will, we could have called it binary because he was UK, British. What's the primary goal of disaster recovery planning? Integrity of data, preservation of business capital, restoration of business processes, or safety of personnel. D, yeah. I'm gonna drive that one home. What business process can be used to determine the outer bound of a maximum tolerable downtime? Somebody's actually on my blog right now.
That's me. They're asking what it was.
Oh,
I had to look it up.
yeah, I get an alert anytime one of you guys is on there messing around. I think I'm
It
not
was me.
watching.
I just posted it. So
No,
you're
it's
gonna
funny.
get, you're gonna get spam now.
Oh. Yeah, oh geez, somebody's refreshing. See, it's cool nowadays. You can get stuff like getting alerts on my phone, on my watch, right? And see what people are doing. I can chat with them too if I wanted to. I could start a chat session. We're not doing that though. Okay, so outer bound of MTD, accounts receivable, invoicing, payroll. So what business process, shipment of goods? And I think what you can read into this question is which of these would be most important to get up and running as quickly as possible? Payroll, right? People like to get paid.
Yeah.
They don't, then they stop showing up. We haven't tried it yet. That would be, oh God, I hope it never happens. But when you started, you know, when you first start, you're like, when we hired Steve, our first salesperson, Kevin and I looked at each other like, how are we going to pay him? He's like, yeah, he's like, well, he better sell some stuff. So thank God he sold stuff. That was the only time I was ever like really concerned about payroll. Your maximum tolerable downtime is 48 hours. What is the most effective alternate site choice? A cold site, that's days or weeks. Hot site, that's probably shorter than 48 hours, probably, you know, minutes, less than an hour. Redundant would be instantaneous. So what does that leave us with? Warm site. Somebody's seriously just pounding the site right now. Tell everybody.
I did. I posted it in the chat.
There's so many friends now. A structured walkthrough test is also known as what kind of test? We just went through this, a checklist, simulation, tabletop exercise, or walkthrough drill. A structured walkthrough. What do you guys think? See? I'm trying to think, I can't remember. It's either checklist or tabletop.
Yeah.
God, because I think they're so close to the same. I'll go with C. Yeah, good one. Yeah. What type of backup will include only those files that have changed since the most recent full backup? That would be a differential, right? What type of tape backup requires a maximum of 2 tapes to perform a restoration? A maximum of 2 tapes. That would also be a differential, right? The last full and the differential.
I was like, from the backup stuff, this is the kind of level.
Kind of questions you'll get. Yeah.
So it doesn't have to be super in depth.
That's good. What statement regarding the business continuity plan is true? BCP and DRP are separate, equal plans. BCP is an overarching umbrella plan that includes other focus plans such as DRP. DRP is an overarching umbrella plan that includes other focus plans such as BCP. Continuity of operations plan is an overarching umbrella plan that includes other focus plans such as BCP. B. Guess I'll set it with like authority. Guess we're using your mind. What HA, that's high availability, solution involves multiple systems, all of which are online and actively processing traffic or data, active-active, active-passive, database shadowing, remote journaling. A, active-active. What plan is designed to provide effective coordination among the managers, right, key word managers, of the organization in the event of an emergency or disrupting event, call tree, continuity of support, crisis management, crisis communications. C, correct. Yeah, and I wouldn't be surprised if I threw crisis management and crisis communications on the same question, because we just need to know that crisis communications plan is part of the crisis management plan, but it's not the plan that they're talking about here. Which plan details the steps required to restore normal business operations after recovering from a disruptive event? Keywords after recovering. Business continuity, business resumption, continuity of operations, or occupant emergency plan. Now this is kind of funny because it's the answer is business resumption, but it's sometimes people refer to it as business recovery plan too, right? In the book, it's business resumption plan. They're both the same. What metric describes how long it takes to recover a failed system? So how long it will take, not how long I have to get it recovered, but how long will it take to recover? Minimum operating requirements. You remember what that is? That's like, heat, temperature ranges, humidity, stuff like that. Those are the operating requirements. Mean time between failures is how long I could expect something to run before it fails. Mean time to repair seems pretty legit. And recovery point objective is about how much data I can lose in the recovery. So that's not here. So that's D or C. What metric describes the moment in time in which data must be recovered and made available? So here we go. This sounds like RPO already. To users in order to resume business operations. Mean time between failures, mean time to repair, recovery point objective, recovery time objective. That sounds like RPO, right? This is good. I wish all my tests were like this.
These are
Piece of cake.
the gimmies in this test, right? So these are pretty realistic questions, and you should read it done and be done immediately.
Yeah, certainly if you've memorized it.
Yep.
If you know what these things are. Maximum tolerable downtime is comprised of which two metrics? Well, we know one of them. Do you remember? One of them is definitely work recovery time. That's how I always just remember that one. So recovery point objective and work recovery time, recovery point objective and mean time to repair, recovery time objective and work recovery time objective and mean time to repair. C is the right one, correct. Which level of RAID does not provide additional reliability? RAID 1, 5, 0, or 3? RAID 0? That's it. What's that? Yeah, for real now, because last time I told you we were done, and then I was like, no, for real, we are done now. All right, let's go on to domain 8. Any software developers here? Application developer folks? Okay, so this might seem a little funky too. And if you were an application developer, you'll see how aged this section of the exam is, or this domain is. If you're not an application developer, a lot of this stuff is going to be new and you're just going to have to memorize it, like object-oriented programming, object-oriented design, and all that stuff and how it works. We're going to go through just basic programming concepts, the different generations of programming from generation 1 to generation 5. Generation 5 is like AI, artificial intelligence, whereas GL1, first generation language 1 GL is like machine code. We're going to go through all that. Application development models, including the ones that are archaic and never worked in real world. Databases, just basics about databases, object-oriented programming and design. Assessing the effectiveness of software security, and then you'll need to know some basics around artificial intelligence. Today, that's all the buzz, right? Everybody is preaching artificial intelligence, and I think 95% of it is BS. I think there's probably some of it where it's actually legitimate artificial intelligence. People also screw up artificial intelligence with machine learning, thinking that those two are the same thing. They're not the same thing. Machine learning is a part of artificial intelligence, but it's not the same. So anyway, we'll go into that. I won't preach on that though. It irritates me, but I'm not going to preach on it. So extreme programming, these are just definitions, terms, concepts that we'll need to know. Extreme programming, the thing about extreme programming is it's agile software development. So agile software development, there's kind of two that are main. One is Scrum, the other is extreme programming. Extreme programming, what makes it different is it's not a team, it's a team of two actually. A Scrum is a team that could be 5, 6, 10. They both use storylines and stuff like that. But the important thing about extreme programming, highlight two, it's a pair of programmers, pairs of programmers that work together. An object, a black box, just like the encapsulation that we talked about when we talked about the OSI model. It's kind of that same concept. Within an object are methods and data, right? And what happens inside of an object is hidden from what happens in other objects, and that's the black box concept around objects. The same objects we're talking about when we're talking about object-oriented programming, right? I'm just taking the way you used to write code was just one big, long, fat program. And so that if I had to make changes, I had to make changes to it was hard, right? But the objects I can do modular, I can reuse objects in one application or another application. I can download objects from the internet, so objects that other people have written, and bring them into my code. So object-oriented programming is kind of a big thing. Procedural languages are those step-by-step kind of, just like procedures that we write down. It's the same kind of language, very rigid to work with. The spiral model is a software development model, and the thing about a spiral model is that there's a risk assessment that's done on every iteration of the spiral. We'll go through that. Software development lifecycle is just a way to kind of, in some development shops, if you say SDLC, I think they'll kill you. Because developers, it seems like, in my years, that developers don't like formality. They don't like documentation. So if you make them follow rules, sometimes they get upset with you too. But software development lifecycle is documenting kind of the whole lifecycle of the from original idea all the way through to decommissioning, taking the application out of production. That whole life cycle for the application. The waterfall model is the one that never really worked. It was kind of came out of the manufacturing world. The problem with the waterfall model is you go from one step to the next step to the next step, and you can never go back. So if I find mistakes at one step of the model, I can't go back. I have to start again. And so that's why, so now what we're going to go through that. The modified waterfall model is what you use now. So anything that's written by human beings, in my opinion, is prone to errors and mistakes. You can't really write truly error-free software. Every bit of software has vulnerabilities in it. It's just whether or not you found them yet. So programmers who just kind of go this willy-nilly, or they don't follow a maturity model, 15 to 50 mistakes per 1,000 lines of code, and that's called a K-lock. K meaning 1,000, LOC lines of code. That's developers. So 15 to 50 without following a maturity model. If I implement a maturity model, I can lower that to as low as 1 mistake per 1,000. So 10 to 15 times less bugs in my software if I implement a maturity model. One of the leading and kind of the pioneers for the maturity model was Carnegie Mellon. The Software Engineering Institute out of Carnegie Mellon wrote the capability maturity model, which is there's 5 steps to the maturity model. I'm going to show it in a minute, and you'll have to memorize that. That's testable for sure. Because we also use that same concept in security assessments. It's not uncommon for people to do security maturity assessments, right? And they're using kind of the same concepts. The methodical framework for creating, good software. That's the link if you want to go to it. That's not on the test, the link. But if you're interested in in more about that, this is the model. So you can see there are 5 steps going from ad hoc or initial to, I usually call it ad hoc. That's one of the characteristics of initial, but it's just kind of whatever, do whatever you feel like today kind of development, up to, where it's optimized. We've got, really solid processes. All the way up till you get there, you're kind of building processes. When you get to the optimized, you're just refining processes. So ad hoc is there really aren't any processes. You start to develop processes in the process definition phase. The process management, we're identifying additional areas where we need more processes. Process control, now they're formalized, and then optimization is really just in making the processes better and better and better. So yeah, I'd say in a security world, most people are, somewhere between a 2 and a 3. If you were to do a maturity assessment of most organizations, it's probably legit. So different types of code. So machine code is first generation. Machine code is, basically ones and zeros. It is CPU dependent. So don't expect machine code, on an x86 system to run on a RISC-based computer, or, even one that you write for a Celeron processor and expect it to run on an Atom processor. They're different architectures, different at this level. So these are run directly by the CPU. There's no interpretation, there's no compilation. You don't have to compile code. It's the computer understands at this level. Source code. The thing to remember about source code, and so this is kind of going out of order, because machine code is an actual generation of programming language. Source code is it's text, right? You've seen source code before. It's human readable code, and usually source code has to be compiled or interpreted by something. The difference between compiled and interpreted is compiled code is converted code that's ready for machine execution, right? So it's source code that's been compiled and made ready for, so that executable is essentially machine code. The computer can run that. Interpreted code, you have to have an interpreter, like a Java interpreter, a Python interpreter. So it's interpreted, it's actually compiled on the fly. So source code is the, what you start with, what you write that gets compiled or interpreted and executed. That's machine code. Look at that, Commodore. You guys ever used a Commodore before? That's machine code. You guys can read that, right? That's hex. No. This is source code. So you can see it's text, it's human readable stuff. You may not understand the language, but it's just like a different language. Like if I spoke Russian and you spoke English, right? It's the same concept. It's just you don't understand the language if you don't understand the source code. But it is a language. Assemblers. So assembly kind of takes it to the next level. These aren't written in ones and zeros. These are written with instructions. So these have to be converted to machine code or machine language. You can see some simple mnemonics for assembly. Have you ever written anything in assembly before? Okay, so you guys aren't super geeks. Me neither, so that's good. So add, sub, jump, telling the machine. They're very limited in terms of the number of instructions, but a little bit easier for you to read than the hex or the ones and zeros that you saw earlier. Compilers take source code in C, BASIC, .NET, whatever, and compile it into machine code. So once it's been compiled, then and so those compilers are machine specific. The source code may not be machine specific, but the compiler that I use to make the machine code is machine specific. That's why what I have on a Windows machine, I don't expect it to run on an Apple machine. It might even be the same source code, but it has to go through two different compilers so that it can run on those machines.
Real quick, my notes on, I was looking that up. My notes on this is similar, used with assembly language on, it's all I needed to know. Compiler takes a high level language and converts it to binary.
Binary.
That's it.
Yep, that's good.
Yeah.
Yeah, no, that is
This
good.
is not my area of expertise, so.
Yeah, I'm a hack. I mean, I can't write an application. I can't like take an idea and make an application out of it, but I can take an application and understand what it says.
Yeah.
It's a
doing that, but
no, but it's a certain skill when you have like Per and Tim are developers here. They can take something and say, oh man, I'd really like to have this. And I'm like, okay. And then 2 weeks later, I'm looking at it.
Yeah.
I can't do that. Interpreters. So interpreters, so really your code is either going to be compiled or it's going to be interpreted, right? There's two sort of types of code or how they get to the machine code. Interpreters are so if I have an interpreter, my same code can be used. It's code independent. That's why the Java code that I write on a Windows machine works on a Linux machine, works on it's the same code. They've just got different interpreters that can take it and compile it on the run. So Perl, Python, Java, those are all interpreted languages. Bytecode is sort of like the comparison to machine code, compiled code. Bytecode is kind of the same thing. It's that intermediate time. It's been interpreted and it's ready for execution by the computer. That's what bytecode is. But if you ever hear bytecode, that's interpreted. If you ever hear machine code, that's compiled.
It's already been.
Right. It's kind of in this intermediary stage. So it's been interpreted but not executed yet. So here are our generations. First generation language, machine code. Second generation language, assembly. Third generation language these are the procedural code, COBOL, C, BASIC. Fourth generation languages are more, they're more than object oriented. They're, GUI based. It's moving things around. It's really pretty easy. And then the fifth generation is AI. There's a graphic. I think this is probably the same one that's in your book to give you. And then this is for those of you who are Darwin people. I'm not a Darwin person, but some people are. If you're a Darwin person, you got it here. So hex assembler, C, Fortran, C++, Java, Ruby. Yeah, so that's it. Computer, okay, so now those are the languages. Any questions on those languages at all? Okay, pretty straightforward. And you don't need to know much more than that. You don't have to know how to develop anything. You don't need to know syntax or anything. No, which is good. So so computer aided software engineering is what the title says is really what it is. It's using computers to help you develop software. So the three types of case software are tools that support specific tasks, workbenches, and then environments are the three different types of case. You might have a question on the exam around this, so I wouldn't spend a lot of time memorizing the case, but now you've been introduced to it. If you've read it in the book, I think you're fine. So top-down versus bottom-up programming. Most of the programming done today, at least the stuff I've done and whatever, is bottom-up. So you start with kind of the low-level code and you kind of build up from it rather than starting with a high concept and writing it from that down. Older programming languages, typically you wrote top-down. Newer languages, you write bottom-up. You take your objects, you take your component, and you build it that way. So that's really the difference between top-down and bottom-up programming. Procedural languages like C, historically top-down, or object-oriented programming languages like .NET, bottom-up. Does that make sense? Open and closed source software. There'll be questions on this, I'm sure, on the exam about free, and there's two types of free software, gratis and libre or whatever. I'm going to cover that. Closed source software that's what, you can't get the source code. You can try to reverse engineer to get the source code, but really there's protections in place to prevent you from getting source code. Usually they're digitally signed, so you'd have to compromise the private key. So you'd have to get Microsoft's private key if you really wanted to look at the source code for like XP and try to do something with it. So released in an executable form, it's been compiled, and what you get are the compiled files in DLLs and things. But the source code is kept confidential. Open source software, you have access to the source code. So you can create your own, in some cases, you can create your own version of that closed source software. Usually it's subject to some, GNU license. So the things the changes that you make, usually you contribute that back to the community. Closed source software, proprietary software, they're not interchangeable. There are some open source softwares that are proprietary. There are that I know of, closed source software that's not proprietary, because otherwise I'd open the source code. But anyway. So free types of software, you'll have to memorize this if it's not self-explanatory. There's different types of free software. There's free as in like free of charge. I don't have to pay for it. And then there's free like, not only do you not have to pay for it, but you can do kind of whatever you want with it, right? You can resell it if you want. You can make your own version of it if you want, whatever. So that's the difference between gratis and libre. Then there's also shareware, right? Shareware is, yeah, shareware's been around for, I was thinking back to the days when I was at Jazz Software, because that's how they made their living, was in shareware, right? You'd use the software and it'd just have some limited functionality, and then you'd pay for the license, and then you'd get the full. That's one way. So that would be an example of crippleware. Other types of shareware are things where maybe you've got a time limit on it, and then it stops functioning, or you have a time limit and then functionality starts to go away. But anyway, that's shareware. Any questions on gratis and libre? We giggling about the freeze and beer? Yeah. That's actually written in license. Yeah, freeze and beer. So software licensing, most software has some type of a license associated with it, whether it's an open license or it's an EULA, an end user license agreement. Proprietary software has that end user license agreement. We all read them. I know I do. Ain't no way I'm installing nothing unless I know what it's doing. Yeah, I've never read one of those. I don't read any legal documents, ever. Kevin reads the legal documents and he tells me if I can sign or not. And then I joke with him. I'm like, yeah, man, I was talking to so-and-so. We had a great discussion, whatever. I signed a couple documents and he was like, say what? Like, yeah, man, it was just, whatever. Like, you did not. He's on to me now, though. It doesn't work anymore, but it used to make him freak out. All right, so end user license agreement. Then we've got GNU and BSD. Those are kind of the two main ones. There's Apache Software Foundation licenses too, but GNU is kind of the big dog. And it's just an open public license. Essentially, you kind of get to use it for mostly anything because it focuses on that free Libre software, but it's meant to keep it that way, right? So I can't take it and own it. That's why when you see like Alien Vault, right? Their software is built on OSIM. I don't know if you've ever heard of OSIM, open source security information management platform. That's where it started. Then they took and made their own version based on that, but they had to keep that other version open because it's subject to GNU. Same with Metasploit. Rapid7 kind of made their own Metasploit, but they still have to maintain the old one, open source. Same with Nessus. Nessus grew from OpenVAS, Open Vulnerability Assessment Scanner. So that's why those things stay open source. So I can do that. I can take anything that's open source, make my own commercial version of it, but there will always be an open source version too. Does that make sense? GNU makes all that happen. Yeah, they call it copyleft, which is their play on copyright. They're funny people, I guess. Lawyers with humor. Is that possible?
There's no way a lawyer can look at that.
Right. It's funny because I think 18 of the top 20 law firms in the state of Minnesota are clients of ours. It's funny about lawyers and jokes about lawyers. I used to say all the time too, like call us anytime you have questions, right? We don't work like lawyers. You're not going to get a bill every time you call us. Now I got to be really careful, when you say that. Like, hey, my wife got a bill once. She was in a coffee shop. We were in Laconia where we live. And there's a coffee shop there, and she ran into one of her friends, in the coffee shop who's a lawyer. And like 2 weeks later, we got a bill for it.
No.
Well, they screwed up, because they have to account for like all their time. And so she must have put in the notes or something that, had coffee with Marlis Francine, and yeah, she got a bill for it.
So you didn't have to pay it.
Huh?
You didn't have to pay it.
Oh, no. Nope. Not paying for that. All right, so software development methods. This is the waterfall method. You see that there's no arrow going back up. That's the big thing about the waterfall method is it's very rigid, no iteration. If I make a mistake, it propagates and you can't really undo it. If you're truly following the waterfall method. 1969, and it was used to describe the development process. I don't know if it's ever been actually followed, in the development process. It does explain it pretty well, but I don't think you can use it. That's that method, and so you'll need to know this. This will be on the exam. You won't need to know the steps, the names of the steps, but you'll need to know what's the downfall of the waterfall method. It's that there's no iteration. So then there's the modified waterfall, and you can see the modified has, we've added implementation, testing, maintenance. We've added these other parts to the waterfall method, and then you've got the arrow back. If there is an error, I can still go back and change it. Traditionally, the modified waterfall method model only allows you to go back one step, though. So you wouldn't traditionally, I don't know, some people probably implement it where you can go back as much as you want. That's one model, that's one method of developing software. So taking software from the concept all the way through to implementation and even death. That's one way you could do it. The sashimi model, you know what sashimi is? It's that fish that's layered, right? So if you know what sashimi is, you know what the model is, because the model is built the same way. It's very much overlapped. Things happen and you don't really know, I think, clearly what phase you're in at any given time in the sashimi model. It's kind of free-flowing-ish. Used by Fuji and Xerox was. I seriously doubt it's being used anymore. But you'll need to know the conceptual things around the sashimi model. Spiral model is another one this one's pretty rigid too. You have to do a risk assessment every time and when I'm saying risk assessment, it's not necessarily a security risk assessment. It's a feasibility risk assessment. It's a business risk assessment. It's kind of a more holistic risk assessment that gets done in the spiral model. 1986, so it's a little bit newer. Repeated steps, so you just keep going around the spiral until you finally get the software done. Yeah, and this is what it looks like. So you start, you go round and round and round, this way, round and round and round, beginning and then out. So that's that one. You can see the stages that are built in. You don't need to know the stages. You need to know what it is and what it looks like. And the one big differentiator about the spiral model is the risk assessment at every phase, at every cycle. Okay, now we're getting into more like real world-ish stuff. So agile software development. I think it's funny when developers write manifestos. It's like, they're the same people, I think, that say, may the 4th be with you. Did anybody say that to you today? Is that today? Is today May the 4th?
Yep.
No.
Anybody say that? Nobody said that to you? May the 4th be with you. There. Come in my Star Wars uniform and but that's what I think of when I think of, I don't know why. That's what I think of when I think of manifestos. I think it's like somebody who's really just pissed off. So I'm gonna write a manifesto. Huh? Or a Unabomber, right. Yep. Yeah. Maybe there's some software development. Maybe he was a software developer. Well, I'm kind of jaded over the years in information security because software developers have always traditionally been our hardest people to work with, right? They don't want, right? No way you're taking admin rights away from my computer. It's like, well, and they don't want to play by the rules. They don't want to not have standing access to production systems, which is a big no-no, stuff like that. So agile software development, a reaction to rigid software development models. The two parts that I mentioned earlier, the two main ones, and two for the test would be Scrum and extreme programming. Scrum, if you ever played rugby, it's named after that. There's a Scrum Master, somebody who kind of runs the Scrum team, and then you work in those kinds of close-knit groups. Whereas extreme programming is just pairs of people, which you usually have Stories are built into these a lot, and then sprints. You ever heard anybody refer to sprints? Software development as sprints. A sprint is we're going to work really hard on this one problem for 2 weeks, and then try to finish that sprint, and then go to the next sprint. But anyway, the Agile Manifesto. So this is what they were manifestoing about. It's a word, manifestoing. We are uncovering better ways to developing software by doing it and helping others do it. Through this, we have come to value individuals and interactions over processes and tools, and working software over comprehensive documentation. Because who needs documentation? Customer collaboration over contract negotiation. Responding to change over following a plan. And then the guy did this. That's what I see. Sorry. Scrum. All right. So named after the Scrum in the sport of rugby, small teams of developers called the Scrum team. It'll have a Scrum master, a senior member, kind of acts, runs the team. The product owner is the voice for of the business unit. So the Scrum master would interact with the product owner. They would have their regular meetings. The rest of the team would be developing and working on their stories. That's Scrum. That's all you need to know for Scrum. Extreme programming pairs of programmers off of a detailed specification. This is getting faster now, faster to market. From where we started at the waterfall that didn't work. Now we're getting closer and closer to sort of speed to market. This is a fast one to market. High level of customer involvement. Like this wouldn't work here very well because we don't have a lot of customer involvement. Because our software development is internal, and a lot of us are busy all the time, so it's hard to regularly check in with our programmers and what they're doing. So for us, this is not the model we follow here. Core practices include planning specifies the desired features, which is called the user story. So we use a bastardized version of this in our scrums. They're used to determine the iteration, the timeline, and drive the detailed specs. Paired programming, programmers work in teams of 2, 40-hour work week. The hell am I doing here? I should be a developer. Don't you think? No, it doesn't mean that they only work 40 hours. It means that their projects are based on 40-hour work weeks. It helps them for scheduling, right? Developers don't work 40 hours usually. Total customer involvement, customers always available. That's why it doesn't work here. Detailed test procedures called unit tests. The important thing to remember about extreme programming is it's an agile development framework and pairs of programmers. The other things are good to know, but those are going to be the really key things for the test.
No.
What, this?
Oh, no, I'll at the end of this.
Oh, okay. So rapid application development, getting software as quickly as possible. What this is mock-ups, multiple mock-ups, right? We're going to mock things up and we're going to code them to the mock-ups, and it's very fast from initial. On a rapid application development, you'd take like a whiteboard like that and you'd map all these mock-ups, and then you take it and you put it in, like what we do. I take them and I put them in Excel. That's a mock-up, and then I take the Excel to the developers, and then the developers sort of like that. What's that?
It's sort of like it.
Well, no. I said it's sort of like that.
I think so.
They love it.
It's sort
Come
of
on.
like that.
Who wouldn't love it? They gotta love it. So the goal is quickly, getting. Usually this would be internal. I don't think that this would be as much commercial. Technical concerns are secondary. The customer is heavily involved in the process. The customer might even be like in the process of this. Usually it's, like I said, internal software development. Prototyping is even taking it even more conceptual and free-flowing. Projects are broken into small tasks, multiple mock-ups, design features. You lower the risk by having the customer really in it all the time.
Real quick.
Yeah.
So RAD and even extreme programming,
Mhm.
the one thing that I had on note that really that you want to know is it's really quick, but sacrifices security.
Yeah,
Right.
okay.
So
Good point.
those two, what's fastball about it sacrifices security. It's either rad or extreme.
Yep, good point. Very good point. So bad security. Not bad, but riskier.
Their speed instead of security.
Yeah.
Would that be true of agile development?
No. You can build security to agile.
Because Scrum is considered agile, right?
Right.
So it's not, and that doesn't have that same weakness.
And we'll see when we get into the software development lifecycle too, how I can overlap the software development lifecycle on top of these models. So these are the models of how the software actually gets done. The things that get done kind of in that comes from the SDLC, which we're going to get to here in just a minute too, but good question. That's rad. Okay, so systems development lifecycle, software development lifecycle. I prefer to use software development lifecycle in the real world because some people think that when I'm saying systems development lifecycle that I'm talking about like the computer system, because that also has a lifecycle. But here it's software development lifecycle. And on the exam, for sure, your software development lifecycle should have security built in at every phase of the process, from original discussion to all the way through to the end. So remember when we talked about certification and accreditation, right? That's part of your software development lifecycle typically. Yeah, so broader, but so you kind of lay this on top of your the models we just talked about. So this is a great reference for if you've never done an SDLC before. This, if you take this and combine it with like OWASP, have you ever heard of OWASP before? The Open Web Application Security Project. You take, those are great references. OWASP has some tools to send your developers to OWASP training. You know, it's a good thing. If they know how to develop code securely and the importance in developing code securely, you'll have better secure code. But NIST 800-14, so prepare a security plan. So we haven't even touched any code. We haven't done anything. We've already developed our plan and how we're going to integrate that into our development project. Then we initiate the project. And developers don't like to invite security people to their meetings. But this is our SDLC and it's been approved by management. I'm showing it. So conduct a sensitivity assessment. So this is getting a little bit, the important part here for the exam is not to memorize. Don't waste any time memorizing these steps. Understand the flow of these. So where I start with like basically nothing and take it all the way through. Understand the flow and understand that security is built into every phase. Those are the key things for the exam. So conduct a sensitivity assessment, development / acquisition. So, you know, some of the software you might buy, some of you might develop. Determine security requirements, incorporate security requirements into specifications, obtain the system and related security activities, and then implement. Install, turn on controls, security testing. There's our accreditation. So the security testing would be the certification based on our, you know, what we knew before. So certification would be security testing. Acceptance of the certification would be the accreditation piece, operation and maintenance, security operations and administration, operational assurance, audits and monitoring, disposal, not just disposal of the software, but also the information in the system itself.
Real quick, what I'm looking through my own notes.
Mhm.
SDLC is systems, SLC is software, there's no disposal. That's how you remember
Yeah.
the two difference.
Yeah,
So
okay.
if you see it, if there's no software, there's no disposal software.
Mm-hmm. Yep.
Yeah.
And remember this note, memorizing the steps that I just went through is not the important part. Understanding the flow is the important part. I don't want you wasting a bunch of time on that. I wouldn't do it. Yeah, so that's that. This is, you know, another SDLC. This is not the same SDLC, but you can see this is another nice one because I can see the process flow where it starts all the way, kind of from initiation all the way to disposition. Disposition means it's been, decommissioned, retired, what have you. And all the steps that go into that. We'd want security involved all the way through. Software escrow, again, we've covered that. That was in the previous domain. It's the same software escrow we're talking about in this domain, and the importance of having software escrow. Your legal requirement with the escrow company or organization in that contract would state specifically under what conditions they can release that software to who, right? And one of those things that might be in there would be under court order, so it is possible potentially for law enforcement to get it too. There's a good story around code repository security. So where you're storing your source code, right, is the code repository, and having good security around that. If you have, especially if it's intellectual property, not securing that source code could be, and it could be construed. You remember back when we were talking about the secret sauce stuff, like Coca-Cola's recipe, right? That's a trade secret. The same thing would apply to software. If I haven't taken reasonable measures to secure that trade secret, then it's deemed to not be a trade secret. The same thing would apply to my code repository and any intellectual property that I have there. If I'm just not securing it at all, you may not have any recourse. List of security control system, operational software, secure communications, so on and so forth. That's all you would apply these controls to your code repository is the point of this slide. GitHub, you guys aren't developed. You guys don't develop. You ever used GitHub before? So you can put other stuff up there too. That's a very popular code repository. Jira. Jira is not a code repository. It's a bug tracking system.
Microsoft actually is moving to GitHub, their internal one.
Yeah, GitHub's legit. APIs are application programming interfaces. So if I want my application to interface with another application, I would have to expose what's called an API. They're hooks into the application, so that you can write, so we can exchange data between our applications. Is it getting cold in here? Okay, good. Good. It's not just me. You guys getting cold?
I can see people getting cold.
Okay, everybody's freezing. So my hand was like, what the hell's going on? Having a heart attack or something up here. What's going
He's
on?
trying to keep us from falling
Need more-
asleep.
Yeah.
I
Need more,
think we're gonna go to hibernation.
need more coffee. That's how you jolt yourself out of a heart attack. Just drink more coffee. So APIs, there's all kinds of different APIs that you could implement. You could implement it in source code. You can open ports, services for API. You could just open up a file share that your application goes and picks up files from. Would be another potential way to do that exchange of information. What happens with APIs is, it's not uncommon for those to be insecure, right? So the implementation of the API, because what I'm doing is I'm opening up a hole in the application to allow your application to speak to it, right? So it does reduce security anytime I do, an API. OWASP, there's OWASP. That's again, the Open Web Application Security Project. They're sort of the authority, not authority. Well, yeah, really good resource for security and application development. They have an API security project designed to address ever-increasing number of organizations that are deploying potentially sensitive APIs as part of their software offerings. Problems with security of API servers are notorious. I mean, if you just think about it, if I'm going to expose an API, that's going to be a target for attack, right? That's a crack in the armor. See if you can exploit it. API or toolkits. So there's a bunch of toolkits. If you have application developers, that's why we send any company that we're working with. It's, one of the questions I ask is, are your application developers, do they do anything with OWASP? Because they have great resources for it. So around APIs, authentication of the API, access control, input validation, encoding, escaping, cryptography, all those things are built into it. You don't need to memorize all that either, but I would memorize OWASP and know, you don't need to know what it stands for, but OWASP will be something very common. And APIs, just at the fact that they are security, they need to be addressed. Security APIs. So software change and configuration management, two different things. Configuration management is different than change management. And it should be pretty self-explanatory when you think about, you know, what those two words mean. Configuration is configuration of the operating system itself, whereas change management, you know, is broader, and it might be across, you know, other parts of the environment or software itself. So slightly different. And these are the things that we preach, right? I can't secure what I can't control. So if I can't control the operating system, if I can't, you know, have some assurance that it's being controlled. So these things here, when you're talking about security-focused configuration management, this same process can apply to your change control. So first, having a change control board or configuration control board, in change control, we would call it a change control board. Those are people with knowledge of the environment that can make a determination whether they should approve this change or defer this change or deny this change, and they can do the risk assessment and do all those other things. Configuration item identification, so selecting, you know, how we're going to handle the items in the change control. The configuration change control itself, managing the updates to the baseline configurations and all kind of the fingers in, and then the monitoring would be reestablishing baselines over time. So once changes have happened, every so often you should audit the system to see if there were any unauthorized changes that were made to that system. And if there were, it's either a policy violation or you have a breach, right? So if you're following something like this. And there's another special publication. You guys all have been to NIST and their special publications page. There's a bunch of really good ones there. A little rigid, so I don't know, most people don't follow them verbatim, right? All right, so object-oriented design and programming. These will be some conceptual things that you'll have to remember for the exam as well. Object-oriented programming is using objects. There's object-oriented programming and like procedural programming is if you're been around for a while, you had to make that transition from procedural programming to probably object-oriented. But it allows me to write chunks of code and make those chunks of code talk to each other. And they talk to each other through what's called messages, right? So, and what happens in this chunk of code doesn't even know about or care about. They just they know that they need each other. There's gonna be two concepts in here. There's gonna be one called cohesion and another one called coupling. A highly coupled object is really dependent on other objects, right? That's a coupled object. A cohesive object is an object that's very independent, right? It doesn't need many other objects for it to function. Those will be two things that'll be, I'm sure they'll be on the exam because they're core components to object-oriented programming. So cohesion and coupling. Coupling is like a girlfriend in junior high, right? Cohesion is like my wife, right?
I'm never gonna forget that.
See? So object-oriented programming replicates the use of objects in computer programs. The design piece is really more about workflow. You know, you would start with most of the time you would start with object-oriented design and you'd sketch out how you want the program to work, and you'd bunch of arrows and boxes and stuff. That would be the object-oriented design. The actual doing it would be the object-oriented programming. So treats a program as a series of connected objects that communicate via messages. Attempts to model the real world, and you'll see when we get into 5th generation languages like AI, that's really trying to replicate what happens in the real world. Examples of object-oriented programming languages: Java, C++, Smalltalk, Ruby, .NET, Python. Those are all object-oriented. An object is a black box that's able to perform functions and sends and receives messages. Objects contain data and methods. You want to highlight that or memorize that. Those are the things that objects contain: data and methods. Method is the same as a function. That's what they have. They provide encapsulation, also called data hiding. Sometimes people refer to it as obfuscation. Yeah, so that's objects, an object-oriented programming at this level. Other concepts that you'll have to know. You'll have to memorize this for the test. If you don't do any application development, you'll just have to memorize things like polyinstantiation and polymorphism and all this good stuff. So objects, methods, messages. Methods are functions. That's so if an object has data and method, a data is just data. The method is what I'm going to do with it, right? How I'm going to manipulate it. That's the function. So methods, messages are the communications between objects. Inheritance is one object is inheriting characteristics of another object. That's inheritance. Delegation, polymorphism. Delegation is kind of the same thing, just sort of in reverse. Polymorphism is an object that can change, right? It would morph into another. Polyinstantiation would be essentially the same object with different data operating in two different places. Is polyinstantiation. It's multiple instances of the object. So inheritance, way to reuse code of existing objects, establish a subtype from an existing object. Delegation refers to an object relying on, that would be coupling as well. Another to provide a specified set of functionalities. Polymorphism, the ability to create a variable, a function, or an object that has more than one form, so it changes. Polyinstantiation, many instances with the same names, different data, right? Memorize this slide. This is testable.
Real quick, my shorthand notes, this is not my area. Aims to minimize time and cost by reusing code, know classes, objects, and message, and what those definitions are. And then polymorphism is an object morphs each time it's executed. And then polyinstantiation, many objects that do the same thing.
Mm-hmm.
That's all I needed to know.
Yep.
So
Good.
just keep it.
Are you gonna? Did you make your notes available? Are you going to, or do you want to? Can you?
Good. I have to go in and clean that.
Don't clean it up. Oh, we'll clean up the swear words and the passwords. Take the passwords.
Password.
So this is just a diagram showing objects. So an object has data and methods. Another object, they communicate with each other via messages. It's pretty basic at this. The concept is very basic. Coupling and cohesion. So coupling is when an object is really dependent upon another object. Cohesion is when they're independent. Highly coupled objects requires lots of other objects to perform basic jobs like math. It's a very needy little object. Those are the objects that kind of tick you off too, right? It's like just always needing something, always complaining. I got to write another object because that stupid object can't do this other thing. An object with high cohesion is independent, right? There's more functions, more methods in those. Right, so any questions on that? That's basically all you need to know for objects, object-oriented programming. Pretty simple. Well, sort of. We're going to get into object request brokers. Object request broker is just like a search engine for objects, right? It's in the computer, in Microsoft things, you have COM and DCOM, right? COM is component object model and DCOM is distributed component object model. All those are search engines for other objects, right? For objects to find other objects. That's all they do. So if you think of that and then just memorize COM, DCOM, and Corba. COM is on one system, right? There's no distributed about it. DCOM is over a network. And Corba is an open source, sort of, you can think of it as an open source version of DCOM. Because COM and DCOM are Microsoft only. Corba is open source, but functions really provides the same thing. So orbs are cool. That stands for object request broker. It's not like orbs, like floating around. That'd be so much cooler. But orbs are middleware, connect programs to programs. You can see sort of actually there's a better diagram. I'll get to it in a minute. Yeah, this one's a better one. So Corba, common object request broker architecture, open, vendor neutral. You can write, anybody can write to it. Competes with Microsoft's proprietary DCOM. It's a message interface, so it's a way for objects to interface with other objects across a network. Using the interface definition language, if you want to know more about CORBA, that's where you can go. It's a network object request broker, and that's basically all you need, and that's it. You don't need to know much more about CORBA than that. Yeah. Not to be mistaken with COBRA, because COBRA is like a healthcare thing. I don't know nothing about that. So here you've got a client server. You see there's a TCP/IP socket. So we talked about that. The reason why I like this one is this one almost kind of fits with our OSI model, right? Where we've got the encapsulation and then, sends it across the wire, and then de-encap. It kind of works a lot the same way. So the client goes through the stub, the CORBA library, it'll be prepared for the network, it'll be connected to, it'll be a service listening on the other side. So, and it just goes back up to finds the object on the server and communicates back. It's pretty simple, for this. Writing to it, I suppose, is harder. I've never done that, but conceptually easy, yeah? CORBA? All right, do I even have any DCOM? Did I even talk about DCOM? Well, same thing. It's basically the same thing. It's just Microsoft dependent. So is there anything in the book about COM and DCOM beyond I just covered? Okay, then I think you're fine. Same concept, same function.
Execute on one to do something on another.
Execute on one to do something on another. Yep, exactly.
There you go. You covered DCOM.
Dumb. I'm dumb. Done.
Thanks, Evan.
Dumb. Done. Not you. I will never call you dumb. So object-oriented analysis and object-oriented design, these are sort of almost synonymous. Like drawing a flow chart on the whiteboard. It's exactly what it is. It's drawing out what it is we're going to build. Yeah, bunch of flow, arrows, stuff like that. Pretty easy. All right, vulnerabilities. It's funny that, does the book refer to 2011? Because it's like 2000, not 11 anymore. But these were the 25 most dangerous software errors, and they're probably the same errors, I'm guessing. Anyway, even if there was a 2017 version. So these are the most common errors. So if I were testing, right, if I were hired to test for vulnerabilities in your application, this is where I would start, right? Just map to these 25 things because everybody else has got problems with these. So one, hard-coded credentials. The developer left in a backdoor, left in, something like that. Buffer overflows. So we're going to go through just briefly what a buffer overflow is. It's also called smashing the stack. But it's really a failure to do bounds checking. Usually, it doesn't happen really much anymore in the object-oriented programming world like it used to in the procedural language world, because C doesn't have any bounds checking built into it. So you'd have to manually code that. In SQL injection, manipulation of the backend SQL server via front-end web server, the actual vulnerability lies in the front-end web application. Directory path transversal with that, that's old. But you could break out of the root web directory with a // I doubt that works anywhere anymore. PHP remote file exclusion. This is essentially just, the file that it's calling, you replace it with your file. The cross-site scripting is within the context of the trusted web server or website. You're going to execute your script. Cross-site request forgery is also within the trusted site, but essentially you're going to redirect to a bad site or bad content. That's all you need to know for these. You don't need to know how to do these, anything like that. Buffer overflow, so no bounds checking. So remember buffer overflow, no bounds checking. And basically what you're going to do is you're going to smash the stack. You're going to think of it as like, taking like this cup and overfilling it with water, right? And it's got to spill over somewhere, right? And so what's going to spill over when you do a buffer overflow is you're going to spill into other memory space where I can then insert my code to execute in that memory space. So it's going to be executing in the context of a different thread, which might be elevated, privileges, right? So it's a way to break out of the application itself and execute code in the memory space of the application. So nowadays, I mean, you would do bounds checking, right? I would limit the inputs. I would limit, what you could do with the application to not allow you just to dump a bunch of data in there and smash the stack. So basically, that's what you need to know for buffer overflow. TOC, TOU, so these are called race conditions. TOC, TOU is time of check, time of use. So there is a very small slice of time when a computer takes an instruction and actually executes on that instruction and then returns the next instruction. So if you can insert your code in the middle of that, then I could potentially execute under the first instruction. So like it's an elevated, it's a privileged instruction. So in this case, it's a privileged instruction to see is the file test readable by the user. That's not going to be my thread, right? It's not going to run under my context, my user account or whatever. It's going to run under the privileged system process, right? So before it comes back, I can implement other instructions that might run under, you're kind of fitting it in between. Do you see what I'm saying? That's what a time of check, time of use. It's a race condition. So you try to get your code kind of in there. It's actually, I think, a pretty sophisticated attack. It's not something that I worry about, but that's what it is. Others, SQL injection, you know what SQL injection is? Basically, it's an input validation problem on, whatever is talking to the SQL server. If you don't validate the input, you could insert SQL instructions that will then get executed by the server. All right, so types of disclosure. I think I referred to it just briefly on Tuesday. When you find a vulnerability, what do you do with it? There's kind of two places and then everything in between. So one is full disclosure. So I don't care about notifying the vendor. I'm just going to put it out there. And, it's sort of, the one thing is it does get the vendor usually to act pretty quickly, right? But I think the motive for that usually is to make a name for yourself, So look at me, the hacker community is going to go, yay, you. And I don't know why you would, go full disclosure right out of the gate. Give them an opportunity. So like if you notified like a software maker that they have a vulnerability and 6 months later they haven't done anything about it, okay, then maybe send another letter and say, hey, yo, I'm going to let people know if you don't do this because we have to protect ourselves. That's different. Full disclosure is like, it's out there. Some people like that. I don't subscribe to that theory much. I think people should get a chance to fix their things before we put everybody at risk. Responsible disclosure is, sharing. It's sharing with the vendor that, you've got this patch, giving them a chance to release the patch and then go ahead and disclose it. So make your name that way. And then there's kind of everything in between. So, and there's a list, the seclist.org, if you want to see some full disclosure stuff in action. Now that a lot of people are offering bug bounties, so like Google has a bug bounty, Facebook has a bug bounty, Apple has a bug bounty. So, and that was, I think, a lot to, one, I get free testing, right? It's like hiring pen testers full time, all the time. That's pretty sweet. And then I would also encourage, you'll have to tell me first before you go tell the world about it. So give me an opportunity to fix it, So that's where people have gone now, is bug bounties. All right, any questions on that? Data buy, that's the pro of database. Data buy, I don't know why they put databases, that sounds dumb. It's totally data buy. So different types of databases. The ones obviously that are the most, that we're most used to would be the relational database, which is you know, kind of the two-dimensional. You've got rows and columns and values in the middle. But there's also hierarchical databases, like DNS is a hierarchical database. You've got the network model. Flat files are potentially databases. And then there's object-oriented databases. So an object-oriented database would be storing executable code in a database, right? So there's, you know, more functionality in how that database works. So different types of databases, structured collection of related data. That's what a database is. This is the most common, is the relational database. These are your SQL servers, Oracle servers, things that, you know, we're used to seeing. Two-dimensional tables, that's the relational piece of it. Rows and columns, right? Column, row, value. The row is called a tuple. I don't like to use that word because it sounds funny to me.
You gotta know that.
You do need to know it, but tuple sounds stupid. I'm so judgmental today. Sorry, guys.
Get it out now so that Tuesday when you're heckling me.
Well, it's not that, yeah, I don't know. Just crappy attitude today. So rows and columns, single cell is called the value. Now, knowing what a primary key will be important as well. So a primary key is unique in the column, but every tuple or every row has to have one, right? Otherwise, we've violated referential integrity, which we're going to get to that too. But that's a primary key. So this is a good example where, because you can choose there's two candidate keys here because there's two columns that have all unique values in them, the SSN and the name. So those would both be called candidate keys. Only one is going to be chosen as the primary key. Now, would it be the name or the social security number that should be chosen as the primary key? It would be the social security number, right? Because people might share the same names. So that would be my primary key. Now, across the side, in order to maintain integrity of the database, every column has to have that value. It can't be null. It can't be the same as somebody else's. So that's essentially what all of this is telling you. Do you understand what I'm saying when I say primary key? Okay. Primary keys will be referenced by other tables. So if your database has multiple tables, primary keys are used to connect those two databases or two tables. The key that's used to reference your primary key is called a foreign key. So if you hear foreign key, that's what that is. 3 types of integrity that we're concerned about. One is referential integrity. So referential integrity means that the foreign key in the other table matches the primary key in the parent table. If you lose referential integrity, then what you have is 2 tables. You don't have a database anymore of 2 tables. Semantic integrity. So that's if this column is strings and I put integers in there, that would violate the semantic integrity, right? So there's types of data that are permitted. If that's not, or attribute data type, if that's not, that's violated semantic integrity. Entity integrity means that across the tuple, across the row, the primary key is not unique or it's blank. That would be entity integrity violation. Get it? Okay. Shaking again, or is that me? Is it me? I don't think it's me. All right, database normalization. So database normalization, there's 3 forms that happen with database normalization. Essentially what you're trying to do with database normalization is to make the database more efficient, take out redundant data, make sure that integrity is maintained throughout the database. That's what normalization does. The 3 steps, the 3 forms, first divide the data into tables, move the data, it's dependent on primary key to another table. I don't think you have to memorize that, but know what database normalization is what's going to be important for the exam. What?
Yes.
Yes, okay. Database views. So database view is just a query, a restricted query, right? I can query a database, and whatever I get back, that's my database view, right? We can restrict access to the database through restricting database views, right? That's what you'd use a database view for. Constrained user interface. Okay, the data dictionary. The data dictionary is sort of the data about the data. It's how the database is set up. It's description of the tables. The schema is part of the data dictionary. Database view information, authorized accounts, privileges, all those things are all part of the data dictionary. The data schema is the biggest piece. It's all the attributes and values and tables that make up the database is all part of the database schema. It's not schema. Database query languages. So two types of languages. You've got data manipulation and database, data definition. So data definition is for creating databases, dropping tables, all that kind of stuff. And then the data manipulation is what you're used to, which is inserting data into the database, taking data out of the database, all that kind of stuff. So DML, DDL, the most common database query language is SQL, 1974. So Microsoft SQL Server is not the only SQL server, right? MySQL, Postgre, DB2, those are all examples of servers that are built to handle and use SQL. There are some SQL commands, just basic SQL commands that you can, some of you probably recall from your own database work. All right, so that's the relational database. Hierarchical database like DNS, it's a tree structure. You've got somewhere in it, you've got a root, and then everything branches out from that. Object-oriented databases are a lot like relational databases, but instead of storing just values, they store objects. So there's more functions and things. They're gosh, what are we looking for? I don't know.
D3.
D3? Mm-hmm.
I was just wondering how to explain it. I think it would be
Oh, D3?
Yeah.
Yeah, I don't know. You know what D3 is? Yeah, it might be. I can look it up. Database replication and shadowing. We've talked about this already. So replication is mirroring the live database to other databases. You can get in trouble with database replication. You see database like I'm thinking of one of our clients who had database replication kind of gone crazy. It's so many versions of their database, kind of all over the place, and they lost control of it. They didn't know where all their databases were. So I don't know, it's kind of weird. But database replication is basically just replicating the database to somewhere else. Shadow databases, like I mentioned before, they're similar to replicated databases. The thing with a shadow database is one of the databases is not active. It's not an active type of configuration. It's an active passive. Whereas replication is, they're both, it's an active. Data warehousing and data mining. Data warehouse, a bunch of data. Sometimes, I'm glad we don't have to go into like Hadoop. Does anybody know what Hadoop is? Yeah, stuff. Okay, so I'm not even gonna go there then. What's that?
Oh, I said I've heard of it. But I don't know.
Okay, yeah. Big data. That's kind of the thing now. But data warehouse, a large collection of databases or data, doesn't have to be in one database. And data mining is looking for patterns in the data, looking for something. Now, if you, gosh, dang it. Data science. There you go, data science. So data science, you start with a question and then you get the data, right? Whereas data mining is more, we have all this data, what's the question, right? It's kind of a backwards way, but that's what data mining is. All right, AI, artificial intelligence. We don't have to go too deep into this. It's good, we're getting good on time. Knowing the different types of AI is what you'll need to know. So you've got expert systems, another one's artificial neural networks. And then there's one other that I've already forgotten. The two main components with expert systems, you have a knowledge base and then an inference engine. the knowledge base. If the knowledge base is flawed, then the whole system is flawed. It'd be like a cancer in your artificial intelligence system. Title knowledge base should follow a tree beginning at the trunk, and then everything branches out until you get to, there'll be a bunch of if-thens until you get to a decision that's made. But the important things to remember about expert systems that are different than artificial neural networks or others is there's a knowledge base and an inference engine. Those things don't exist in the others. So if you hear knowledge base or inference engine, you're talking about an expert system. Artificial neural networks, kind of the same way your brain works. We've got a bunch of synapses and they all fire and stuff like that. It's meant to replicate that. The human brain has 100 billion neurons. I have 63 left. They're connected by thousands of synapses each, and those synapses all connect and communicate and whatever. It's pretty crazy. So knowing what an artificial neural network replicates, I think is the most important part for you in the exam. If you're not working with artificial neural networks or artificial intelligence, I don't think you have to go much deeper than that. This is an example of an artificial neural network and its communication and interaction with each other. There is a learning piece to actually a really big part of the artificial neural network is the learning functions. So it's a trial and error. It's the same way we learn, right? I learned not to put my hand on something hot by putting my hand on something hot, right? And then that went into my memory bank in this case, sort of like an artificial neural network. It'd be like a memory, but it's not a knowledge base like an expert system. But it would learn, next time don't do that. That was the wrong choice, right? Works the same way. Fuzzy. So fuzzy stuff is like it says there, like predicting the weather. It's not an exact science because you can't build it like that. You can't build 100 billion neurons very well yet, but maybe someday. Then it gets creepy. Would you guys be creeped out by? I mean, does this creep you guys out? No, well, neurons, well, yeah. No, but like artificial intelligence. It's like, where does it end? Ends through destruction. That's what it ends with. Well, I'm just telling you, it's going to be a while.
Skynet comes online.
Huh?
Skynet comes online.
Skynet, yeah. Oh, has anybody seen that? Is that movie out yet? That one with the circle?
The circle, yeah, it did that.
It did that? Did it really? It looked good.
It
Trailer
looks
looked good.
good. I like it, but. I
Oh, did you see it?
Not yet.
Okay, yeah, I have to see it. All right, Bayesian filtering. So Bayesian filtering is really simple math, really calculating probabilities. You see Bayesian filters, really where they became famous was in identifying spam. And it was looking for specific triggers, things that were characteristic in spam emails, but it was all based on math. That was the really cool part, not that they could detect words in emails. But those things became indications that they were spam. Spam filters are still using Bayesian filtering. Genetic algorithms and programming, trying to replicate nature. This is where it gets freaky. When you tell me, where is it? Did I put it in here? Where is it? I've got, oh, where did I see it? Crap. This is where, I don't know. This is basically where programs have sex with each other. Reproduction.
Are you talking about the crossover?
Some breeds.
Yeah. So you tell me code is like, what? This is where it loses me and I get freaked out, right? You're telling me like my computer's gonna be having sex with your computer? That's, no. How do I protect it?
How do I protect
Or wrap it in plastic or something? So genetic algorithms and programming, sort of, this stuff kind of freaks me out a little bit, but It replicates nature's evolution. So things die, so you start with a bunch of programs and then they kind of evolve and they eliminate, so if the ones that made poor choices end up getting killed off and the ones that made good choices live on, and then they replicate and that's this. It's weird. Yeah, I'm not swapping code with nobody. Ain't no way. So that's genetic programming, right? So the thing to remember for the exam, genetic programming replicates nature, just as a bigger interconnected kind of organism thing. So initial population of random computer programs, execute each program in the population, assign a fitness value, so which ones make the cut, and then create new populations of programs. Oh, there's sexual reproduction. Yeah. Copy the best existing programs. I mean, it's getting kind of weird. But this is what they've already used it for, right? And this is back when the book was written, and this is based on older content. So it's come a long way since then. Pac-Man playing programs, robotic soccer teams, network intrusion detection systems. I don't mind that one so much, but it gets weird. That's it. We've made it through the entire book in 7 weeks, 6, 7 weeks. How many weeks has it been?
I don't even know.
12, 6 weeks? All right.
Yeah.
So we have no more additional content, the things other than, the things that you pick up when you read. But we've now been through all of it, right? And so now it's honing those skills. For me, I would equate this to going through the book that first pass. When I studied first pass, you guys are probably beyond that, but the first pass, I didn't really know what a lot of this stuff meant. I didn't know how it all fit. But when I read it, maybe this is the first and second pass, but now it's focusing on the mastery of it and then, passing the exam. So we'll do the test on Tuesday. I'll be here late, but I'll be here. And then you guys are all ready. I mean, seriously, I think all you guys will pass this thing easy. How much does it still cost? Like $400? 600?
600.
It's a freaking racket is what it is. Ain't no way. I'm gonna send my computer over there to have sex with their computer. I get this thing for free.
There was one of the questions is if they pass or when they pass, what do they do for endorsement?
Oh, send it to me. Yep, send it. Send your. Now it's all electronic, so you can send your endorsement to me along with your resume. I'll look through the resume. Oh, and Brad. No, yeah, you're
I haven't
right.
endorsed anyone yet.
Send them to Brad then.
They're gonna be like, oh, how did he do this for so many hours?
Yeah, you should do it. Yeah. So when you pass the exam, myself or Brad will endorse you. I do it all the time. I do it with people even that have, like, there were a couple between classes that had watched the videos online and then went and took their exam and then asked me if I would endorse them. So I hadn't even met them before.
Yeah, I figure if you pass it, you're doing something right.
Yeah.
Yeah.
One more question is, will they be going through on Tuesday the sample? Will it be just all the modules, or will it be a mix? It'll just be
Mix.
right?
Good.
Like,
Yeah. I think it should be a mix because a lot of the stuff that we covered, in domains 1 and 2, be nice to refresh that with some more challenging questions instead of the booky ones. Yeah. Do you have content, or do you have an exam site that you go to or have gone to?
I'll have to go back and look.
Because if we don't, I can help you find something.
I've got a ton of stuff. So I can figure it out.
Or otherwise, you can use the book one. But is anybody else planning here to use the book one?
I don't want to use.
No, you don't want to use the book one?
Well,
Okay.
if they're going to use it,
Yeah, it's
just give them
okay.
like just one.
All right, we'll find something. That's it. I'm going to bed. Sick of all this.